Hello, I'm Liesel Ehlers and I'm going to present a lesson on mathematics, NCV level 4. In our previous lessons we have looked at the rules of differentiation and we actually applied those rules to answer some questions on tangents. In the second lesson we actually used it to answer questions on rates of change. And now in this lesson we are going to apply differentiation to actually be able to draw cubic graphs. Now, what should you go and learn? What must you know about cubic graphs that will help you? The first thing you should know is the shape. Well, let's start by what is the basic form of a cubic graph. Cubic graphs can be written in the form ax cubed plus bx squared plus cx plus d. Now, this b, c, d can be 0 as well, but there must be at least an x cubed. So, the shape will be determined, or the shape, if I want to know the shape of this cubic graph, I can look at the a value, the value in front of the x cubed. So if this value is greater than 0, in other words positive, I will remember, well, how I do it is I remember the smiley face and then I add a little pod in front. If the a is less than 0, in other words, it's negative values. A negative value, I remember that sad face and then I add a little pod in front, so that will remind me how the shape will look like. Other things you should know is, like for the x-intercept, y will be equal to 0, but that's true for all graphs. If I want to determine the y-intercept, I replace x with a 0. Then the turning points, remember we already mentioned that. At the turning point, it's the only place where the gradient is exactly 0. So it's where the derivative is 0. If I want to determine this local minimums and maximums, I want to decide actually which one of these turning points are a local max and which one is a local minimum, I can use second derivatives. If the second derivative for a specific x value comes out greater than 0, positive, then it's a minimum, local minimum. If the second derivative for a specific x value comes out something negative, then it's a local max. Then the point of inflection will be when the second derivative is equal to 0. So that's the theory, things you should actually know and learn. Let's look at a first example. In this example, they say, given below is this sketch, and they give me f of x equal to x cubed minus x squared minus 8x plus d. And they say d is a constant, and the question is, determine this value of d. They also mentioned that b and c, they are the turning points, as I can see on the sketch, and point A is an x-intercept. Well, A is an x-intercept. Isn't there another x-intercept as well? Yes. B is also an x-intercept. B is actually a special x-intercept because B is an x-intercept because the graph is touching there on the x-axis, but it's also a turning point. Okay, the question says, determine the value of D, the unknown that I have there. So the thing I know is I have a point that is lying on the graph. And if the point is lying on the graph, it means if I substitute it into the equation of the graph, it's going to make the equation true. So this point has got an x value and a y value. And if I replace the x and the y into the equation, I'm going to replace all of it except the d, and that's what I want to actually determine. So let's substitute. I'm going to start by substituting into the f of x that I have the point 2, 0 because it's lying on the graph. In other words, I've got an x value and a y value. In the place of the y, I'm going to substitute, in other words, the 0, which will be equal to x cubed minus x squared. Oh, sorry, I forgot to replace the x value. The x value is 2, so if I replace it in the place of the x, and I replace again the 2 in the place of that x, every x is replaced by 2, then the only unknown I've got is d. In other words, 0 will be 8 minus 4 minus 16 plus the d. So what do I have? 8 minus 4 is 4, 4 minus 16 is negative 12 plus the d is equal to 0, and if I get the d separate, d will then be equal to 12. Okay, so now I know the value of D. Let's look at the next question. The next question says, now calculate the coordinates of A. Now, where's A? A is that point here, and we can see on the sketch that A is actually the x-intercept. So what I want to do is I actually want to determine the x-intercept, or x-intercepts. Okay, for the x-intercept, what do we know? For the x-intercept, I have to replace y with a 0. And if I replace y with a 0, it's going to be 0 is equal to x cubed minus the x squared minus the 8x plus the d. But now we know d is going to be 12. So I can replace the d with a 12. So if you like it more, you can actually say all of these terms will be equal to 0. And now I have to solve the x. But how am I going to factorize this? Maybe you will remember you should have done maybe previously the remainder and factor theorem. The remainder and factor theorem is the thing that's going to help me now to find at least one factor so that I have one factor that will go into this expression that I have here. So I'm going to look at f of a certain number, certain value. I need f of a certain value that will give me 0. And once I got f of a certain value that gives me 0, then x minus that number will be a factor. Now let's try f of 1. If I replace every x here with a 1, I'm going to get 1 minus 8 plus 12. Okay, and that is going to give me 4. Okay, it's not 0. Let's try something else. If I try negative 1, then it's going to give me, and I replace it in there, it's going to give me negative 1 cubed minus a negative 1 squared minus 8 times negative 1 plus 12, okay, which is negative 1 minus a 1 plus 8 plus 12. This gives me 18. Still, I haven't found something giving me 0. Let's try f of 2. Okay, if I replace every x with a 2, 2 cubed is 8, minus 2 squared, which is 4, minus 8 times 2, which is 16, plus 12. Now this is minus 20 plus 20. It's 0. So once I found the 0, you can actually say, so x minus this value 2 is a factor. And once I know at least one factor, I can actually, well, there's more than one method. I'm going to use long division in this method, in this case. I'm going to use long division. There's also another method which I will address in another example. So at this stage I can say, I can do long division. And x minus 2 will perfectly divide into this x cubed minus x squared minus 8x plus the 12. Okay, x must be multiplied with what to give me the x cubed? It must be multiplied with the x squared. So once I've got that value, you have to actually take it and multiply it with both values there. Let's do that. So I'm going to get x cubed minus 2x squared. And now I have to subtract. X cubed minus the x cubed is nothing. Minus 1 of this x squares plus 2 is going to be 1x squared. And I bring down the negative 8x. The process will repeat. X must be multiplied with what to give me the x squared? 1x squared is a positive x. And the moment I write it there on top, I multiply with both. So it's going to be 1x squared. If I multiply, positive and negative is negative 2x. Subtract. Negative 8 plus 2 is negative 6x's. And I bring down the last term, which is a plus 12. Let's repeat the process. X must be multiplied with what to give me that negative 6x? Well, I have to multiply it with negative 6. And the moment it's up here, I multiply it with these two terms. Let's do that. Negative 6 times the x is negative 6x. Negative and negative is a positive 12. And if I subtract, I'll get nothing. So I have divided the x minus 2 into the expression, and I have got the other factor. So x minus 2, we said, is one of the factors. The other factor will be x squared plus x minus 6. Okay, it's a trinomial, the second bracket. Let's see if it can factorize into more brackets. If it can't, I'll have to use the quadratic formula. So x times x, the negative here says the signs in the brackets will be different. So it means I will have a plus and a minus. What is the factors of 6? It can be 2 times 3. 2 times 3, let's say I want a positive 3 and a minus 2 because I have to end up with this middle term. Plus 3 minus 2 will give me the plus 1x that I want there in the middle, which means the one bracket is 0 or the other bracket is 0 or the other bracket is 0, which means the x is 2 or the x is negative 3, or for the last bracket x will be equal to 2. Now, this is just a quick hint. If you see, as we have in this case, that some of the x values are actually, x-intercepts are repeating, then that point where x is equal to 2 is also going to be a turning point. So in my sketch, it's those two x values is actually, they are referring to this b, the point 2, 0. So they are referring to the point 2, 0, which was the one x-intercept. So the other one, the actual question was, what is the coordinates of A, which must then be negative 3, and because it's lying on the x-axis, the y value will be equal to 0. So this question was, what's the x-intercepts? And I have determined that. The next question says, determine, question 3, determine the coordinates of C, point C. Now, if I look at my sketch, I'll see point C is a turning point. So in other words, I'm actually have to determine the turning points. Okay, what do we know about turning points? We know at the turning point, the derivative will be equal to 0, because at the turning point, the gradient is equal to 0. So the derivative must be equal to 0. What is the derivative of this graph? Remember, d we know at this stage is 12. So the derivative will be 3x squared if I differentiate the first term. If I differentiate the next term, it will be minus 2x minus 8 plus 0 is equal to 0. So again, because it's a quadratic equation, I have to factorize it. And I'll try and factorize it. I know x times x will give me this x squared. Then I have to look at the factors of the 3. Let's try 1 times 3. And I look at the factors of the 8. Let's try 2 times 4. Before I go there, let's quickly put in the signs. If the last sign is a negative, it means the signs in the brackets will differ. So it will be two different signs, positive and negative, which I have to use. Okay, so back to the factors. 3 is 1 times 3, 8 is 2 times 8. If I cross multiply, 3 times 2 is 6, 1 times 4 is 4. I have to use a plus and a minus, but I want to end up with this negative 2 in the middle. Okay, so how will I get negative 2? I'll put negative 6 plus 4, which will bring me to the negative 2 that I want, which means in the negative bracket, I have to put a 1 and a 2. In the plus bracket, I put the 3 and the 4. And now I factorized it, so the one bracket must be equal to 0, or the other bracket must be equal to 0, which means x is equal to 2, or 3x is equal to negative 4. And if I divide with a 3 then both sides, I'm going to end up having negative 4 over 3, which is the same as negative 1 and a third. So the two x values, they didn't ask me both turning points, they asked me actually just C. So the one value that I got was x is equal to 2, but that is referring to this turning point that they actually gave me. So that one is referring to that point B. So the point C must be this one with the -4/3 as an x value. Do you see they asked me actually the coordinates? So I can't just give them the x value, I also have to give them the y value. And in order to get the y value, I'll have to replace into the original equation every x with a -4/3. So every x is replaced with a -4/3. It must be squared, then 8 times this -4/3. And then plus the 12. Now, you will be using your calculator to save a bit of time. I already calculated that to be 18,519, approximated to 3 decimal places, which means my final answer would be C is the point. Let's put them both approximated to 3 decimal places, -1.333. That goes with 18.519. Okay, in our next question, it's a new question. Here I'm being given the expression, the equation of gx. Gx is equal to 4x cubed plus 15x squared minus 18 plus 6, x plus 6. So I've got a new expression, gx. Now, they ask me determine the coordinates of the turning points. Since we have already done turning points in a previous question, let's just quickly go over this one and rather focus on the other questions. So, for turning points, what do we know? At the turning point, the derivative will be equal to 0. So, the derivative of this g must be equal to 0. And I differentiated it. 3 times 4 gave me the 12x squared. 2 times 15 gave me the 30x minus 18 x to the power 0, and this derivative must be equal to 0. I actually saw that 6 can divide into each one of those, so I simplified it, and then I factorized it. The one bracket must be equal to 0, or the other bracket must be equal to 0, which gave me x is -3 or x is a half. And then, to determine the coordinates, I have to take this -3 and substitute it into the original equation. So every x will be replaced with a -3, which gave me 87. The same, if I replaced every x with the other x value, half, I got an answer 1 1/4, which gave me this 2 turning points. Now, let's see what's the other question. The next question says, if you are given now still this gx, the one that we have determined the turning points of, what is the question? They say by applying second derivatives, show which x value produces a local maximum and which one produces a local minimum. So maybe we should quickly remind ourselves on what we should know. What we should know is, if the second derivative for a specific x value is less than 0, then it's a local max. If the second derivative is a positive value, then it will be a local minimum. So let's try and use second derivatives. In our first question, we actually used first derivative, so I just wrote it down for our convenience. Let's see now. I need the second derivative. So it means I need the derivative of this derivative. And I'm going to differentiate each term. If I differentiate this term, I'm going to get 24x plus 30x to the power 0. And then the last term will be just 0, which I don't have to write. I want to actually now find out, if I replace the x with the -3, which was the one x value of the turning point, will this answer come out positive or negative? Because that's going to determine whether it's a local max or min. And if I replace the half what am I going to get then? So I'm going to also replace the x with a half. So if I replace the x with a -3, 24 times the -3 plus the 30 give me -42. If I replace every x with a half, then I'll get half times 24 is 12 plus the 30 is +42. Okay, so let's just see what we have said there on the screen. We said that if it comes out negative, the second derivative, then it's a local max. So I can conclude to say here I've got a local maximum. And where it's positive, it will be the local minimum. In other words, if I go back to this turning point -387, there where I had a -3 will be the local maximum turning point, and the other one will be the local minimum. In the next question they say, determine the coordinates of the point of inflection. So do you still remember what we should know about the point of inflection? The point of inflection is where the second derivative is equal to 0. And we already used the second derivative, so I can actually just use it. The second derivative, we said in our previous question, is 24x plus 30, because the point of inflection will be where the second derivative is equal to 0. So it's where the 24x plus 30 is equal to 0. In other words, when the 24x is -30. And if I divide now with a -30 both sides, I'll get -30 over 24, and if I simplify it, it's -5 over 4. So, but that's just the x value. What's the y value that will go with it? For the y value, I'll have to replace this x value into the original. So if I replace this x value of -5 over 4 into the original, I have to actually replace every x value with -5 over 4. Minus 18 times -5 over 4 plus 6. You will be using your calculator. I used it and I got 353 over 8. Approximated to 3 decimals, it will be 44,125. What is the point of inflection? In other words, it is -1.25. That will go with a y value, 44,125. Okay, let's look at another question. It's still referring to this equation g of x. And we have done some calculations at this stage. If I can refresh you, the calculations that we have done, we said the following. We said the turning points we calculated, and we actually decided which one is a local max and which one is a local min. So the first thing they say now, which graph below best represents the function g, A or B? So let's see, if we take what we have, we said here, the point -387 is a turning point. So -3 must be on this side of the x-axis because it's negative. The other x value of a turning point must be a half, which will be here. And with -3, we actually had a y value of 87, which we can see it can't be here on the negative side of the y-axis. So it's not here. Let's see, -3, the x value -3 will be on this side. Yes, 87 can be read off here, it's positive. And even the other turning point, if that is a half, a positive 1.25 as the y value that goes with it. So in other words, I'll conclude and say this one is the graph that will represent the g. We are going to move on to another question. In this question, they say, this graph represents the third degree polynomial h of x. So now I've got a new function. The function is h of x. and here is h of x. It cuts the x-axis at P, Q, and at R. The question is, determine the roots of h. Now, firstly, I need to know, what is this roots that they are talking about? Remember, roots is just another word to say they want to know what is the x-intercept. So actually, they could have actually asked me, determine the coordinates or the x-coordinates of P, Q, and R. So I want to determine the x-intercepts. So for the x-intercepts, I have to replace y with a 0, and this is the y. So if you replace the y with a 0, all of these terms will be equal to 0. So to save a little bit of time, I already said, well, I have to search for something, h of a value that will give me 0, so that I can have at least one factor. Now, I tried a few. I tried h of negative, I tried h of 1. It gave me 8. H of negative 1 actually gave me 0. So I had something that will give me 0. If h of negative 1 is 0, it means x minus this value that I used, minus 1, is a factor, which means x minus minus 1 is a factor, which means x plus 1 is a factor. So if x plus 1 is a factor, I can actually go back and say, I know one of the factors are x plus h. So now, this function that I have, those 4 terms must be equal to x plus 1 times a certain a squared plus bx plus c. And I need to find this a, b, and c. So what I know at this stage is if I multiply the x with a ax cubed, that's the only way I'm going to get x cubes. In other words, ax cubes will be equal to what they have given me, negative 1x cubed. So I can conclude by saying a must be negative 1. If I multiply the last value of the one bracket with a c of the other bracket, then 1 times c is c. And what is this constant in the given equation? Well, it's 6, so c must be 6. So at this stage, I know this. I know what they have given me is equal to x plus 1 multiplied with an a, which I know, plus b that I don't know yet, plus the c. Okay, now only thing I have to still determine is the b value. So how will I get x squares? Because I know negative 2x squared is given in the original equation. So the only way I'm going to get to x squares is when I multiply this and those two. So which means I'm going to have negative 1x squared plus the bx squared, those are the ones that's going to give me x squared, must be equal to what was given, negative 2x squared. If I take out of x squared as a common factor, negative 1 plus b must be negative 2x squared. Do you see that negative 1 plus b, the coefficient of the x squared on this side must be the coefficient on the other side, which means b is equal to negative 2 plus 1, which is negative 1. And there I have it. I know the ax squared. The a, we said, is negative 1x squared. The b value, we said, is negative 1. And the c value, we said, is 6. And there I have the 3 x-intercepts as they asked. So this was the last application of differentiation, and in our next lesson we are going to look at the opposite of differentiation, which is integration.